Hello, everyone, and welcome to this HSB webinar. My name is Katie, and I will be your Global Spec moderator. Now I'd like to introduce today's presenters. With us today, we have Michael Fitzgerald. Michael is a Nuclear Business Development Manager at HSB. Also with us today is Gavin Edley. Gavin is a Technical Manager with HSB. Michael and Gavin, welcome to today's event. And with that, I'd like to pass things over to you to get us started.
Thank you very much for joining us today. Our webinar is an introduction to the initial edition of ISO 19443, first published in 2018. During the webinar today, first we'll talk about the history and evolution of quality management system standards with a specific focus on ISO 9001, and also discussion about the nexus for the birth of ISO 19443. Second, we'll discuss the structure and key requirements of ISO 19443. And finally, we'll walk through the path to certification and maintaining certification. For this first section, we'll discuss the events that led to the development of ISO 9001 and its continued evolution to the standard we all know today. We'll also discuss some industry-specific application of the ISO 9001 Quality Management System Standard, in addition to discussing the development of ISO 19443. According to the 2024 ISO survey, there are more than 1.4 million ISO 9001 certificate holders worldwide, over more than 2.3 million certified sites. For those of us who aren't familiar with ISO 9001, it's a consensus standard that sets a structure and set of requirements for quality management systems. The adoption of any quality management system within an organization is a strategic decision, which is made to help improve that organization's overall performance and provide a sound basis for sustainable development initiatives. The key aspects of ISO 9001 are a customer focus, commitment of leadership to quality outcomes, a process approach, a focus on continued improvement of the organization, evidence-based decision-making, and relationship management. When implementing a quality management system, it's not just about checking boxes or following a list of rules. It's about thinking in terms of processes. ISO 9001 promotes what's called a process approach, which helps organizations better manage their activities by understanding how different parts of the system interact. Instead of seeing tasks in isolation, the process approach encourages you to see the bigger picture, how each process connects with and affects the others. By managing processes as part of the cohesive system, organizations can improve both their efficiency and effectiveness. This means achieving better outcomes, reducing cost, meeting customer expectations more consistently, and ultimately enhancing customer satisfaction. This slide shows the Plan, Do, Check, Act cycle, sometimes called the Shewhart cycle, which was originally developed by the famous quality thinker Walter Shewhart. Another version of this cycle is the Deming wheel, named after W. Edward Deming, who popularized this approach in his quality teaching. In World War II, production quality became an important issue, with many incidents of unsafe or unacceptable military equipment being identified during 100% inspections being performed at the end of production. Mass inspection was quickly showing that it was not a suitable means to ensure product quality. In response to the issues experienced during World War II production and continue to be experienced by the United States' early rocketry and aerospace programs, the U.S. Department of Defense developed MIL Q9858. This military standard laid the foundation for quality management systems. The British Standards Institute introduced its first quality standard, BS 9000, in 1971, which was focused on the electronics industry. BS 5750 was issued in 1979 and was driven by the United Kingdom's Ministry of Defense's requirements. The first edition of ISO 9001 was published in 1987 and shared a common structure with BS 5750. The structures continue to evolve based on worldwide feedback, with major revisions occurring in 1994, 2000, 2008, and the most recent edition we're working off today, 2015. There's also a pending revision of the ISO 9001 standard expected to be issued later this year. Quality management systems, industry-specific quality assurance systems, and component-specific quality control plans differ primarily in scope, purpose, and level of detail, though they work together to ensure overall product and service quality. A quality management system, or QMS, is the broadest framework. It defines how an organization manages quality across all processes, from leadership and planning to document control, audits, corrective actions, and continual improvement. Standards such as ISO 9001 are requirements to be used in developing a QMS. A QMS focuses on how the organization operates to consistently meet customer and regulatory requirements rather than on individual products or parts. Industry-specific quality assurance systems build on the general QMS framework, but add requirements tailored to a particular sector. Specifically for the nuclear industry, the American Society of Mechanical Engineers NQA1 is an example. These systems tend to emphasize preventative assurance, ensuring that industry-specific risk, regulation, and performance expectations are systematically addressed throughout design, procurement, manufacturing, and service. Component-specific quality control plans operate at the most detailed level. They define the inspection, testing, acceptance criteria, sampling methods, and documentation for a specific component or process. The QC plans focus on verification, confirming that an individual part or assembly conforms to defined acceptance criteria or specifications during or after production. On March 15, 1994, U.S. Defense Secretary William Perry communicated to the Department of Defense and defense contractors a shift was needed from the current management philosophy that attempted to achieve high quality and performance through after-the-fact inspections to one that prevented defects through controlling its processes and reviewing process controls of its vendors. The message was clear: focus on process controls rather than hands-on inspections. On June 29, 1994, Perry issued a directive that outlined a preference for performance and commercial specifications over military specifications and military standards. With that stroke of a pen, the department no longer had a quality management standard to reference for aerospace programs. To fill this gap, the Society of Automotive Engineers developed AS 9100, a quality management system standard tailored to aviation, space, and defense industries. When the aerospace industry examined ISO 9001, they saw gaps, particularly in the areas of design, development, manufacture, assembly, reliability, maintainability, servicing, regulatory compliance. Rather than trying to patch those holes with specific requirements in purchase orders or contracts, the aerospace industry saw a benefit developing a quality assurance standard tailored to their needs. The first edition of AS 9100 was issued in 2000. While initially focused on the requirements for defense programs and procurements, the aerospace industry adopted the use of AS 9100 for civilian aviation programs and products as well. Requiring AS 9100 qualification for vendors shows aerospace firms that those vendors have the controls necessary to provide products of adequate quality and reliability, ensuring that their vendors can meet the stringent requirements to maintain safety of flight. Beyond the aerospace industry, other examples of industries that have tailored ISO 9001 for their quality and safety needs include IATF 16949 for the automotive industry and ISO 13485 for medical devices. NSQ 100 was initially developed with a strong focus on supporting the quality requirements of the EDF nuclear supply chain, especially for new builds and upgrades like the European pressurized reactor projects. EDF is a driving force in the nuclear industry. as one of the world's largest nuclear operators. They also played a central role in launching and applying the requirements of NSQ 100. Specifically, NSQ 100 was created to, first, standardize supplier expectations across EDF's expanding supply chain, ensured non-French suppliers could meet EDF's strict nuclear QA needs, and also harmonize procurement and audit practices for EDF's EPR projects, both domestically and abroad. Additionally, major nuclear firms like Areva and Framatome also needed a common QA language for their suppliers worldwide, many of whom did not have nuclear sector specific experience. At first, NSQ 100 didn't function as an official international standard, but more of an industry-guided framework to bridge the gaps between ISO 9001 and EDF's nuclear performance and quality expectations. Nuclear safety is dependent on traceability, risk assessment, and configuration control. While NSQ 100 encouraged practices to improve controls in these areas, ISO 19443 sets clear requirements in specific clauses. ISO 19443 also presents a common determination approach to assess if products or services are important to nuclear safety, meaning that structure, system, or component performs a safety-related function within that nuclear facility. ISO 19443 also establishes a framework for implementing a graded approach for quality assurance controls. NSQ 100 was originally a designer-specific standard, primarily initiated by EDF and its industrial partners, but intended to be applied across EDF's extended supply chain, including international vendors. As the adoption of NSQ 100 grew, so did the feedback about its implementation, as well as interest in developing an international standard for the nuclear industry. Early efforts from the International Organization for Standardization's Technical Committee 85 started early in 2013 and ultimately led to the publication of ISO 19443 in May of 2018. After its publication, we've seen a slow but growing adoption of ISO 19443 globally, and as ISO 19443 is adopted, NSQ 100 is being phased out. ISO 19443 adds to the baseline requirements of ISO 9001 to meet the nuclear industry's specific needs and expectations. The standard adds requirements for nuclear safety culture, prevention of the use of counterfeit, fraudulent, or suspect items, requirements for applying a graded approach to quality assurance controls, and a determination process for products or services important to nuclear safety. ISO 19443 does not replace an ISO 9001 program, but instead builds on the foundation that an ISO 9001 compliant quality management system establishes. The next section will introduce 19443 in more depth. Specifically, we're going to talk about the purpose and scope of ISO 19443, how it differs from and builds on ISO 9001, how it applies the core requirements, including nuclear safety culture, the determination process for items important to nuclear safety, and risk-based thinking, and also identify organizations' responsibilities as a supplier to the nuclear industry. Development of ISO 19443 was a collaborative effort between the International Organization for Standardization and the International Atomic Energy Agency, and is based on the 2015 edition of ISO 9001. Feedback from the development and implementation of NSQ 100 jump-started the standards development, as we've discussed earlier. When we review a page of the ISO 19443 standard, we'll find the baseline requirements from ISO 9001 contained within boxes. Nuclear-specific requirements that have been added are outside those boxes. In this way, organizations with an ISO 9001 compliant quality management system currently have a clear and direct path for establishing a nuclear quality assurance system by addressing these clearly identified additional requirements. Please note that the informative annexes cited in ISO 9001-2015 are not included in this document. ISO 19443 builds on the quality management system requirements of ISO 9001 with a specific focus on nuclear safety, with enhanced principles that are intended to be implemented across the entire nuclear quality management system. As we've discussed, ISO 9001 focuses on the quality management principles of customer focus, leadership, engagement of people, the process approach, continual improvement, evidence-based decision-making, and relationship management. ISO 19443 adds the principles of nuclear safety culture, determination of items important to nuclear safety, as well as a graded approach for the application of quality assurance requirements. ISO 9001 scope focuses on an organization's ability to consistently provide products and services that meet customer and applicable statutory and regulatory requirements, while enhancing customer satisfaction. Rather than prescribing technical or product-specific requirements, ISO 9001 is process-based and emphasizes understanding organizational context, customer needs, risk-based thinking, and the effective management of interrelated processes. The intent of ISO 9001 is to promote organizational effectiveness and continual improvement through disciplined planning, execution, performance evaluation, and improvement of processes. It encourages leadership and accountability, employee engagement and evidence-based decision-making, and proactive management of risk and opportunities. As a result, ISO 9001 serves a foundational quality framework that can be adapted to many industries and is often used as a baseline upon which more specialized or regulated quality standards, such as ISO 19443, are built. ISO 19443 takes the framework from ISO 9001 and tailors it to the unique needs of the nuclear industry. Specifically, to the scope of organizations that supply items or services important to nuclear safety and activities on licensed nuclear sites that require the licensee's oversight. In this way, the requirements within ISO 19443 are a framework to meet expectations of the customer, but are not a substitute for customer and/or regulatory requirements. In the nuclear industry, licensees have the ultimate responsibility for nuclear safety. For products or services at nuclear facilities, licensees translate the appropriate quality and technical requirements into procurement documents and use them as a mechanism to formally communicate to their suppliers. The fundamental quality requirement for the nuclear supply chain is identifying the quality assurance controls that products or services will be delivered under. Having a quality assurance program that meets prescribed requirements tells licensees that their suppliers have the necessary controls within their program to ensure products or services that are delivered meet the technical requirements prescribed in procurement documents. ISO 19443, like any other nuclear quality assurance program, can be flowed down as a requirement from the licensee to suppliers and down to sub-suppliers. ISO 19443 follows the same structure of ISO 9001. The 10 clauses and their key elements are shown here. Additional nuclear quality assurance requirements are layered within the baseline requirements from ISO 9001 when needed. A main difference between ISO 19443 and many existing nuclear quality assurance standards is the focus on continual improvement, beyond conforming to prescribed requirements. Continual improvement initiatives within many quality management systems create an opportunity to decrease the overall cost of quality while ensuring customer expectations and requirements are fully met. This approach is more proactive than the reactive approach contained within legacy nuclear quality assurance programs' requirements for corrective actions. While there are many activities at a nuclear site and products and services provided by suppliers that have an impact on nuclear safety, not all are within the scope of ISO 19443. This standard does not include requirements specific to other management systems, such as those for environmental management, occupational health and safety management, security management, nuclear material accounting and control, or financial management. Additional systems and/or controls will need to be implemented within nuclear organizations to meet these requirements. Some activities that are specifically outside of the scope of ISO 19443 are given below as an example. Quality assurance professionals working in the nuclear industry are familiar with the requirements contained in the American Society of Mechanical Engineers NQA1 and the Canadian Standard Association's N299 series. When compared to ISO 19443, ASME NQA1 is more prescriptive and detailed, defines explicit QA requirements and controls for nuclear safety-related activities, is directly referenced by ASME's Boiler and Pressure Vessel Code for the construction of nuclear components, and is widely embedded in U.S. regulatory practice. Within NQA1, the graded approach for quality assurance controls is discussed, methodology is implied, but there remains uncertainty on the acceptability of specific approaches and space for differing interpretations. An important perspective that is frequently missed is that the scope of ASME NQA1 is focused on nuclear facilities and then flowed down to their suppliers. This is given in NQA1's title, Quality Assurance Requirements for Nuclear Facility Applications, and is explicitly stated in the first sentence of the foreword. CSA's N299 series, unlike NQA1, are a set of quality assurance standards focused on the requirements for vendors, derived from the N286 requirements for licensees. The graded approach is explicit in N289 and has 4 distinct layers, the most restrictive of which is contained within N289.1 for items that have a direct impact on nuclear safety, and the least restrictive within N289.4 for items being supplied to nuclear facilities that are close to commercial grade. Both ASME NQA1 and N289 are dependent on the organizations procuring items, performing audits to verify the controls of their suppliers, and qualify them to provide products and services. Alternatively, ISO 19443 is based on independent third parties performing audits to verify adequate controls within nuclear quality assurance programs and their implementation at facilities. Another significant differentiator of NQA1 and N289 is their acceptance by nuclear regulators. However, we are seeing early acceptance of ISO 19443 as an alternative by several regulators within Europe. For our final section, we will discuss implementing ISO 19443 controls within your quality assurance program, as well as the certification process. Having a strong and compliant nuclear quality assurance program reduces regulatory risk and simplifies audits by nuclear clients and regulatory authorities. This prevents the risk of clients placing additional controls on your orders prior to their shipment, which can cost your business additional time and money, as well as expensive enforcement actions from regulators, which may publicly damage your reputation within the industry. Secondly, the ability to leverage third-party audits for suppliers and continual improvement efforts internally will help drive lower cost, simplify documentation, and speeds up qualification for nuclear contracts. ISO 19443 allows organizations that already have a 9001 compliant program to add the nuclear industry requirements directly on that quality foundation. As an example, most regulators have requirements or expectations on nuclear safety culture, both for licensees and for vendors. In order to meet these regulator expectations, many licensees flow down safety culture requirements within purchase orders and by supplier procedures. Exact safety culture requirements and procedures, while similar, are almost never identical between nuclear utilities and other nuclear firms, leading to confusion and space for missed requirements. Instead, ISO 19443 embeds nuclear safety culture requirements that are common within the standard, simplifying that complex space. Finally, third-party certification can work to build trust and strengthen commercial relationships in the nuclear sector. Through audit sharing organizations like NUPIC, NIAC, and CANIAC, many nuclear vendors are already dependent on third-party audits, forced to accept these audits on only the documentation provided to qualify their suppliers. Independent third-party certification demonstrates to clients your readiness to meet their nuclear requirements has been verified, both within your nuclear quality assurance program and implemented in your production activities. When asked, any vendor may report that they have a nuclear quality assurance program that meets their customers' expectations. Maintaining an ISO 19443 certificate demonstrates to your customers and prospective customers that your organization is committed to nuclear quality. The pathway to obtaining ISO 19443 certification, while possibly difficult for some organizations, is very clear, and it starts with the commitment of your leadership. Modifying or extending any quality assurance requirements is going to take an investment of time and effort from your organization. And the commitment from leadership allows you to make that investment and take that step forward. From there, you can leverage your existing ISO 9001 program if that's the quality management system you have in place, or alternative quality management systems such as NQA1 or N299.1. The natural next step there is to perform a gap analysis, to look at your current program and to look at the requirements and identify especially where are the largest gaps and how to fill those holes. As you perform that gap analysis, it's important to consider the personnel and examine the technical and quality training needs of the organization to meet these new requirements. From there, a methodic approach to updating both the quality assurance manual that you intend to use for certification to 19443, as well as the supporting procedures, is an essential requirement to address all of the 19443 requirements in the standard. Right? Specifically, common gaps are nuclear safety culture procedures, procedure for determination of items important to nuclear safety, as well as how the quality assurance approach will be graded for nuclear QA activities. As you engage in this endeavor, it's important to gain feedback from your nuclear customers on their requirements. That'll give you perspective on the modifications you're making to your quality assurance system. Then it's time to implement the updated program. And like any new program, there'll be hiccups and flaws, but that's the entire purpose of your corrective action system and your internal audits, is to find where your program doesn't work well and drive to that continual improvement. And after those periodic reviews, internal audits, and assessments are done, that information needs to be fed back to management as part of the management review to feed back in their continued support to sustain your nuclear quality assurance system. On the last slide, we talked about what your organization will do to prepare for ISO 19443 certification. On this slide, we're going to talk about the role of the certifying body. The first step, which is optional, is a pre-audit. Sometimes we'll refer to this as a stage 0. If your organization isn't confident about the changes you made in your quality assurance system, you can use your certifying body to come in and give a practice stage 1 to assess the controls you've implemented within your program. The first required step is the stage 1 audit. These are relatively short, usually 1 to 2 days. The purpose is to assess the documented controls within your nuclear quality assurance program to ensure that they cover all the requirements within ISO 19443. In this way, the Stage 1 assesses your organization's readiness to move forward to a full Stage 2 audit. I do want to note, though, if the audit team identifies any nonconformities during the Stage 1 audit, they'll expect those nonconformities to be fully closed prior to coming back for the Stage 2 audit. The Stage 2 audit is multiple days in length, but that's really dependent on the organization's size and scope. Usually they're scheduled between 1 to 3 months after completion of the Stage 1 audit, but in any case, no more than 6 months. The purpose of the Stage 2 audit is a full assessment of the nuclear quality management system, as well as its implementation against all of the ISO 19443 requirements. If auditors raise any nonconformities where deficiencies against the ISO 19443 standard are identified, these nonconformities will be required to be resolved and closed within a 3-month period. And at the end of the audit, during the closing meeting, the audit team will make a recommendation either to issue or deny certification pending satisfactory closure of any nonconformities identified during the audit. From there, the audit team will issue the audit report and possibly any notification of nonconformities to both the organization being audited as well as the certifying body's technical team. Internally, the certifying body will form an internal review against the documentation submitted. Once the organization has closed any nonconformities and there's objective evidence in the audit report and response on any nonconformities that the organization fully meets the requirements of ISO 19443, then the certifying body will issue a 19443 certificate. Once the initial certificate is issued, it's maintained on a continual 3-year cycle. Not more than 12 months after the original certificate is issued, the certifying body will perform a surveillance and will be followed every year thereafter. And the surveillances will take a sample. It's a smaller, shorter duration audit that just takes a sample of the quality assurance program and its implementation. That ongoing feedback ensures that your organization's nuclear quality assurance program still meets the requirements of 19443. Then on year 3, for the recertification audit, the audit team will take a full look against all the requirements of ISO 19443 to support a recertification and issuance of a new certificate. This cycle will continue on 3-year cycles for as long as your organization chooses to maintain an ISO 19443 certificate. One important note is that this certification process requires clients to be actively producing items important to nuclear safety. It's essential because it gives the certifying body's audit team a sample of work performed to verify implementation of controls for the nuclear quality assurance program. If no nuclear work has been performed in the period since the last surveillance or audit, additional audits may be required when production starts again. Thank you very much for joining us for this discussion on ISO 19443 and its implementation today. The HSB team is looking forward to answering your questions on ISO 19443.
Hello, everyone, and thank you, gentlemen, for such a great presentation. So we are going to move into our live Q&A session at this time. All right, gentlemen, I'm going to grab our first question that we have here in our queue. So this person is asking, ISO 19443 isn't a requirement in my jurisdiction, so why should I become certified to ISO 19443?
Absolutely. Yeah, I'd love to start off with this question. And I think that the 2 strongest reasons, first start with cost of quality, and then second, demonstrating maturity to your prospective clients. So first off, on cost of quality, the nuclear industry is known for high cost of quality. It has the one of the highest cost of quality among many heavy manufacturing industries. Instead of using kind of the legacy approaches and controls within many of the existing nuclear quality assurance standards, the continual improvement drive within 19443 will help you find the right controls for your processes depending on what you're trying to produce. And with that flexibility, I think organizations will be much more successful in lowering cost of quality while maintaining a high quality and a conforming product or service. The second piece is about demonstrating maturity of your quality management system and readiness for clients. A lot of organizations perform audits across the board, right? And so it's not uncommon for organizations to have some sort of audit in a database that looks like they're available and ready to do a scope of supply that aligns with your needs. But I'm sure many of us have been in the position before. You go and perform an audit of that organization, you find big gaps. That's one of the fundamental strengths of third-party certification. Third-party certification uses highly qualified, highly focused auditors with specific experience and background, both in the nuclear industry, but that specific technological sector. And so by doing that, I think you get the highest quality audit, and you can have confidence that if someone has a 19443 certificate, they have a quality management system that's going to meet your expectations to the standard.
Great, great. Thank you so much for that answer. All right, moving on to our next one here in the queue. All right, this person is asking, my company currently has an ISO 9001 program and sells items for the nuclear industry. How hard is it for me to grow my program to meet ISO 19443?
I can take this one, Katie. It's Gavin. So, if this is your situation, 19443 is pretty much, it's what it's made for, your sort of organization. So it's a little bit difficult to generalize and say for everybody that it's not a huge gap to bridge. But if you are a current 9001 certified organization and you are already operating within the nuclear supply sort of like sector or chain, you will typically already have like some of the 19443 requirements embedded within your program. You'll still need to do a gap analysis, so that there is still, some small, some significant gaps that sort of need filling. But what we tend to find is things like the nuclear safety culture, for example, that's required in 19443. If you're already in the nuclear industry, even though it's not really a 9001 requirement, most nuclear suppliers will have some sort of nuclear safety culture, sort of like ingrained within their organizational culture. So typically what we see is existing 9001 companies who are relatively active within the nuclear industry. It is an effort, there's still work that needs to be done. You'll need to do a gap analysis and bridge the gaps. But it tends to be a manageable effort to go from 9001 to 19443. Whereas some companies that we see who don't have 9001, so maybe operate sort of like other quality systems, it can be a little bit of a bigger gap to jump to the 19443 requirements. So hopefully that answers that one.
All right, Gavin, thank you so much for that answer. For our attendees, we do have a ton of questions in our queue, so thank you so much for your participation. So that just means we probably won't get to all of them today, but keep adding those in and we'll get back to you following today's webinar. All right, I'm going to move into our next one here, and I'm going to kind of pick two of these together that seem to work well, so I'm going to combo these. The first one is, can one manually address ISO 19443 NQA-1, N299, and N285? And then kind of going with that, do we require separate quality manual for iOS 19443?
Yeah, I can take this one again, Kate. So the real question is here, can you use one ISO one manual to address 19443 and many other standards? The answer is yes, but if you manage to accomplish it, you are doing incredibly well. Generally speaking, having one manual to cover these different standards will be difficult to do. 19443, it doesn't formally require a quality manual. It requires you to have a sort of like a written description of how you meet 19443. The most common way to do it is to have a quality manual for that. But what you can find is quality manual is a much high level document, and you tend to have to write it to meet a specific standard. When you're using it to meet sort of like several other standards, it becomes increasingly difficult to try and describe how you meet sort of like unique requirements from each standard. So it can then also get complicated if you are audited against these individual standards and you have a comment in an audit that, oh, you don't address this requirement, we need you to revise this part. Instead of just revising a part of the manual for like one of these different standards, you end up having to revise, you know, a part of the manual that applies to all of the standards. And then it has knock-on effects about, you know, maybe you have to get that manual reapproved by your certifying body. So in general, in theory, it can be done. In practice, we typically do see separate manuals, especially for 19443 and NQA1. Now, as you move below the manual, so keep in mind the manual is like a high-level document. As you move below the manual and you get into your procedures and your work instructions, and you will have procedures and work instructions that cover all of these standards in a single procedure. We don't typically see those split, but at the manual level, as I say, at that very high top QMS description level, in theory it can be done. In practice, at the moment, we typically see separate ones just so they can address the individual nuances of each standard. I hope that answers that one.
And Michael, did you want to jump back in to touch on the other question that we had asked earlier?
Yeah, it's a great question about for whether 19443 QMS certification being required or that the QMS compliance only to 19443 being required. And I think a lot of that's going to depend a little bit on the jurisdiction, right? I think in the United States, we've seen some regulatory hesitancy for requiring certificates. I believe that's held true in the Canadian market as well. And I think if you look at the European market, especially around product lines like the, or requirements like the European Pressure Equipment Directive or the Construction Product Registration, I think there's more of an appetite to require that. Beyond the kind of jurisdictional requirement, I might add that the for ISO standards, they exist in a third-party certification structure, and there's a lot of background by how certifying bodies are supposed to work and implement. And so I have seen some discussion where people are, they kind of essentially look for the direct audit version of those management systems, quality management systems, environmental management systems. But you're almost like trying to play soccer with a football playbook, right? I think the ecosystem around ISO is really kind of built to support from a third-party certification perspective. And so I think you'll get a naturally better outcome that way. It's not wrong, but again, I think the actual requirement will be driven by jurisdiction, but I do see the value add of third-party certification.
All right, thank you, Michael, for jumping back over and wrapping up that question for us. So as I mentioned to our audience members, lots of questions in the queue, so keep them coming. And gentlemen, I'm going to jump over to this one here. This person just saying good morning, good afternoon, or kind of wherever we are in the world. Asking, I understand that the time frame for certification applies to a company with an established system, but what about a company that doesn't have ISO 9001 certification? How long would that take?
Okay, it's Gavin. I can take this one again. So a company who doesn't have an established ISO 9001 certification system, it's kind of one of those questions that, like how long is a piece of string? It really depends on what sort of quality system they have established already, or what sort of quality system they are operating to already. And then also how many resources can they throw at the establishment of a 19443 quality system. So just to give sort of like some examples, and this is just very, very typical sort of timeline. So if you have a 9001 system and you're going for 19443, sort of like it can take, maybe it could take up to 6 months plus to prepare you to jump that gap from 9001 to 19443. If you are jumping straight from, as I say, a different quality system all the way to 19443, you potentially are probably looking at anywhere from 6 months to maybe over a year, depending where you start from. So what quality system you have sort of like originally. And the examples that I use for that are things like nuclear safety culture. So that's a requirement in 19443. Having a nuclear safety culture it's not like a light bulb where you can turn it on and off sort of like at a moment's notice. It's something that has to be grown within the organizational culture of a company. It needs to have roots, it needs to grow, it needs to be taught, it needs to be established. So if you already start from a position in that you might not have a 9001 system, but you already have, high level procedures, you have a nuclear safety culture sort of like already. As I say, you may work to NQA1, for example, but just not to 9001. Then you don't have too much of a gap to sort of like bridge. But to come from no quality system at all to 19443, that is quite a step to take. And normally, most manufacturers for that would probably take the step to 9001 first before moving to 19443 if you're coming from sort of like a zero basis. So yeah, apologies that I can't give you like an exact time frame, unfortunately. It really does depend on what you have at the moment with regards to an existing quality system and how much resources you can throw at this project in order to prepare your company to be compliant. Hopefully that answers that one.
All right, Gavin, thank you so much for that answer. All right, next one here. We're going to grab this question. What defines a nuclear safety culture?
Yeah, thank you very much. So this is such an obvious question. Now I kind of have to wonder, why wasn't it at the presentation? Right? So a nuclear safety culture are the core values and behaviors shared within an organization, especially with leadership, that prioritize safety above all competing objectives, including cost, schedule, and other programmatic objectives. By taking this stance, it helps ensure that every decision and action that is made keeps the protection of people, environment, and the impact of nuclear materials in mind, right? But when we look at nuclear safety culture, it has a little bit of an interesting history. Nuclear safety culture really comes from operating facilities. It was largely developed through the actions of the Institute of Nuclear Power Operations and the World Association of Nuclear Operators from that kind of operational standpoint with support from regulators. When nuclear safety culture transitions from the nuclear facility to nuclear vendors or nuclear constructors, it looks a little bit different. It's kind of natural that way. And I think part of one of the strengths of 19443 is rather than being put in the position as a organization of having to adopt an external nuclear safety culture that may be defined by your clients, it gives you the opportunity to define your own that aligns with the products and services you deliver, your organizational structure. And by having that direct ownership, I think it's going to make it a lot more successful for the quality and safety outcomes for your organization.
All right. Thank you so much, Michael, for that answer. So for our audience members, we have about 8 minutes left in the webinar, and we have a ton of questions in our queue. So a few of you will be getting a response from us following today's webinar. Thank you all so much for these great questions. All right, gentlemen, we're going to grab a couple more questions before we run out of time today. This next person is asking, do ISO 19443 implementers and their customers believe that it on its own provides adequate protection of nuclear safety, the same as ASME NQA-1?
I can take this as well, Katie. So, yeah, basically the intention of 19443 is to sort of provide this high-level assurance, the same as what NQA-1 does of a manufacturer's sort of like quality system in order to supply into the nuclear supply chain. One of the key differentiators with 19443, though, is that it's a third-party certification of the quality system, whereas what happens in NQA-1, companies sort of like operate an NQA-1 quality system, and that quality system is then audited by the purchaser or the licensee, sort of further up the supply chain. And with this, it kind of creates like a little bit of a redundancy in that if you are using or if you are supplying to multiple purchasers, you may have to then go through sort of several audits in order to prove to each customer that you are compliant with NQA-1. And what 19443 does, with it being like a third-party certification, it allows purchasers to specify 19443 as a quality standard, and the manufacturers or the service providers, they can then gain this 19443 certification via accredited certification bodies, etc. And by doing that, it then allows this confidence to be able to supply to multiple purchasers and prove to each individual purchaser that you have this quality system that meet these requirements. So yeah, it seemed very, very much on the same level. And I know that there is comparison documents as well between NQA-1 and 19443. They are different, but when you look at the fundamental requirements of them, they come out roughly equal in their requirements, especially with regards to nuclear safety. So hopefully that's answered that one.
Yeah, Gavin, and I would just add that when we look at NQA-1, it's really a prescriptive standard. Right? It's a prescriptive standard due to ASME boiling pressure vessel codes incorporation of NQA-1 for Section 3. It also gets a lot of feedback for those pressure retaining components. But when we try to use NQA-1 to procure more diverse things, the prescriptive controls that are there may not be as well tailored to those types of products or services, or maybe even fundamentally lacking, right? And so while NQA-1 has some clear guidance that are laid out in parts 2 and 3 that are additional beyond the baseline requirements, it has limited flexibility. Alternatively, 19443 by being performance-based, makes you pick the right controls for the outcome. So if you're looking at an organization that may have a broad array of products and services, that gives you maximum flexibility to align the right controls with the right products, right? So if we're to imagine maybe a large engineering, procurement, and construction contractor, at the end of the day, they got to buy a lot of stuff, and they got to control a lot of different processes, right? In the right kind of procurement methods and controls and quality processes for procuring pipe spools aren't going to be the same ones for procuring some sensitive reactor I&C equipment, right? And so by this way, trying to tailor to what the product or service is, having the right controls for the desired outcome in place, I think you're going to get a better output, as well as, again, try to lower that cost of quality for the level of quality that's achieved.
All right, great. Gavin and Michael, thank you so much for that answer. So we have a couple minutes left. I'm just going to grab one more question to kind of wrap things up today. If my company receives ISO 19443 certification from HSB, would our ISO 9001 program also need to be with HSB?
I can take this one, since we're running out of time. It's a very simple answer to this one. No, it's not required that they are from the same certification body. So if you have a 9001 program with certification body A, you can seek 19443 certification with certification body B, for example. So it's not required that it's the same body, no.
All right. Thank you so much, Gavin, for that quick answer at the end there. So we are right at the top of the hour. As I mentioned, thank you everyone so much for your participation and so many great questions. We love the engagement today. So thank you, Gavin. Thank you, Michael, again, for a great presentation and for taking all these questions. Gentlemen, it was a pleasure to have you.
Thank you.